Okay, so good afternoon. I don't know if it's morning for you, but it's afternoon for me. For those of you guys that are on quarantine or whatever, I thought I would post a quick video about how to do some factoring. This is actually what we're going to be doing on Thursday the 13th. So if you are gone on Thursday the 13th, this is the set of concepts that we're going to be looking at. So I'm going to take you over here to a screen right here. We're going to be dealing with something that's called algebra tiles right here. And these algebra tiles are these shapes right here. So you'll notice this shape right here would be x squared. It's this guy right here, this blue guy. Now, as it turns out, we have x squared. We also have negative x squared. So again, if it is blue or it is red, I probably should have used different pen colors to denote that. But again, anytime on these you're dealing with a red, that's what happens. So like here, this is a 1. I guess I'll switch over here and I'll make that in blue. In fact, I'll go ahead and make this one blue as well. So anytime it is blue, it's going to be positive, and anytime it is red, it is going to be negative. So that's going to be -1, okay? Now, similarly, we have these weird little tiles that look like this. Now, what you'll notice is these tiles have the same width as the 1, but they actually match up with the x squared this way. So this particular tile is 1 by 1, which is 1. This tile is 1 by -1, and this tile is 1 by x, which is x. Now notice I did that in blue because that's the positive version, or if I flipped it over, it would be -1 by x, which is -x, which I should do again in red, okay? So as we go through those problems, these are the building blocks. And when you factor, what you're really trying to do, if you think back, if I said, hey, let's go ahead and factor the number, say 6, you would break it into pieces that is 2 times 3, or in other words, 2 things whose product or multiplication is that. So what I want to do is I want to turn this thing right here, x squared plus 6x plus 8, into something that is a product that is that. So I'm going to build that up. I've got x squared. I've got 1, 2, 3, 4, 5, 6 x's. And I have 8 single ones. Okay, so let's see what that looks like. Let's see, let's count those out. 1, 2, 3, 4, 5, 6, 7, 8. Now, what I'm hoping to do is ultimately create a rectangle that does that. So now notice if I tried this, that's x squared plus 6x plus 8. Again, my goal is to make a rectangle. So what if I did this? Would this actually legitimately make a rectangle? Well, when I go like that, I filled it all in. It's pretty good, but I have a couple of missing pieces. So that doesn't look like it quite worked. But maybe instead, if I slid one of these down here to the bottom and I rearranged it just a little bit, what you'll notice is it did perfectly make a rectangle, didn't it? Now, as it turns out, I'll just kind of try to show you what that looks like. This is my shape right here. Now, again, from here is x. We said each of this is 1. Remember, it was 1 by x. This is x plus 1, 2. So my first side is x plus 2. And again, if I took x plus 2, the length times the width, this is x plus 1, 2, 3, 4. So I just found that if I could multiply x plus 2 by x plus 4, in other words, base times height or length times width, I would actually get this answer right here, x squared plus 6x plus 8. So let's see if we can try that again. So again, this time we're going to go x squared plus 5x's plus just 6. So it looks like I think I have that set up right. Now, x squared plus 5x plus 6. So the first thing that I would do is, again, I usually like to kind of go in the middle. Does that work? I still have extras. So maybe what if we did this try again and we did 2 here and that one there? Oh, that kind of works. Now, sometimes people might be like, oh, wait a minute, that's not the only answer. Maybe there's another way to do it. So notice that when I did this, my height is x plus 1, 2. That's x plus 2. And my width is x plus 1, 2, 3. That's x plus 3. Now, keep in mind, somebody else might have said, oh, I did it a little bit different. I took one of these and I put it down here. And if you look critically, does that also work? And you can see that it does, but that is x plus 1, 2, 3 by x plus 1, 2. So we have x plus 3 by x plus 2. So it's really the same answer. We just did the two things flipped over, and that's the same thing. You know that 4 times 5 and 5 times 4 is the same answer. So these answers actually are unique, and there's only one way to do them. So there we go. We're kind of done with that problem. Now, sometimes we go ahead and make things just a little bit harder. This time I have 10, so let's see, I got 2 more. There we are. There's x squared, and we've got my 10, but it says we have negative 1, 2, 3, 4, 5, 6, 7. So just like before, let's see what happens if we try maybe 3 of them here and 4 of them here, because that would make 7 x's. See, did that actually do what we wanted? So if we start sliding those pieces in, it doesn't look like I have quite enough x's to fill this thing out. So right now it doesn't look like maybe I did it right. Or maybe the problem just isn't doable, but we could try something else. Like, what if maybe instead of doing this, what if we tried to take both of these down here? Well, did that work? No, because we've got all these extra pieces. But maybe instead of taking both of them down, maybe I just took one of them down. And what do you know? It worked. And so again, if I wanted to look at that, this is x. And remember we said if it's red, it's minus. So that's minus 1, 2, 3, 4, 5. So this one is x take away 5. And this one is x and a minus 1 and a minus 2. Now, I know you might look at this and think that's kind of crazy. But remember, these are negative. This part is negative 5. 1, 2, 3, 4, 5. This part is negative 2. And a negative times a negative is a positive, and so that actually makes sense. Okay, now, to kind of finish up my story is as follows. I'm going to go here one more time to look at another piece because I would like you to try to do these two on your own, and I'll have that in the paper so you can actually try that. But the last part, so you can hit pause for a second, but number 6 and number 7, those are going to be trickier because I'm going to try something new. So the first thing that I would like you to notice is, say this is 2, right? There's 2 x's. This is a negative x, and this is a positive x. So it's 2x right now, but if I added an x and I took an x away, it still says 2x, but in a different way. See, I could keep adding 1 and taking 1 away, and I would continue to have those x's. So what I'm going to start with is I'm going to start off with x squared, and I'm going to start with negative 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So here's my 8 negatives. Now the thing is I know in this problem I have 2 negatives, but I don't know anything else. But somehow I'm going to try to see if I can make these work out. But you know, obviously, if this thing right here is negative, I either have to have a negative times a positive or a positive times a negative. So what I'm going to try is a couple little things. It still says negative 2. So let's see. Would this work? Could I get away with this? Would this make the pattern work? And I think you can see it doesn't quite work. So let's try another one. Let's maybe put another negative here and another positive here. Now keep in mind, every time I add one of each, I've actually kept things steady. And what you'll notice right there, I think we did okay, because now we do have a nice, easy rectangle. Sorry, I'm messing this thing up a lot. And what we will see then in the way this played out is this is x plus 1, 2. Remember, the blues are positive. And this is x minus 1, 2, 3, 4, x minus 4. And that actually worked, and that's okay because a positive 2 right here times a negative 4 right here, positive 2 times negative 4 is negative 8. So last one is number 7. Let's see what happens on problem number 7. We're going to start with x squared. We're going to start with 3 x's, and we're going to start with 10 negatives this time. Now again, with 10 negatives, we're going to have something like, I don't know, maybe something like this, but I need this bottom little piece to end up being a rectangle, and that's not a rectangle. So the only way I can make a rectangle is either maybe 2 by 5 or 5 by 2. So I'm not really sure what it's going to be, but I'm going to start by adding 0. I'm going to put a 1 and 1 there. So if I put 1 here and 1 here, it doesn't quite work yet. But if I put 1 more here and 1 more here, now it actually works. And you can see that as I keep adding it, it actually eventually works. And maybe I would have messed up and I would have wanted the rectangle to be this other direction. And that's okay, but in this case, I could see that if I kept trying, it worked. So there we go. We have our story. Let's see how we got it. Put it all back in there. So this is x plus 1, 2, 3, 4, 5 multiplied by x minus 1, 2. And that's how you factor. And so I will also post for you the rest of the assignment this particular day. For Thursday, we're going to be doing a couple little things. So we're going to start with a factoring, and then we're going to go on to diamond problems. So if you don't remember diamond problems, we're going to start with some questions that look like the following. And ultimately, these are going to kind of play off together. So in diamond problems, sometimes I don't draw the full diamond. Sometimes I do something a little bit different. In a diamond problem, you have something like this. If we have a 3 and a 4 here, I forgot I didn't share. Let's go back and share that thing. But in a diamond problem, you end up with 2 problems on the side, and their product goes on top. That's 12 because that is 3 times 4. And the sum goes in the bottom, which would be 7. So in that way, if we had this story right here, the diamond problem, if we had a -8 and a 2, then their product, -8 times 2 would be -16, and -8 plus 2 would be -6. And some of the problems are easy, like if you have these 2 numbers right here, it's very, very simple. But sometimes you don't have that part. Sometimes you do it a little bit different, and you tell them the answer to the product and the sum. So for example, we had a 10 here and a 7 here. So I need a couple of numbers that multiply to 10, like it could be 1 and 10, or maybe 2 and 5. But somehow they have to add up to 7, and I can see that 1 and 10 do multiply to 10. So does 2 and 5, but 1 plus 10 is not 7, but 2 plus 5 is. So that is my diamond. Sometimes the problems are easy. Sometimes they're a little bit harder. So this would be an example of a problem that is quite a lot harder. So what if this time I went ahead and I did -60 and maybe -11. Now that would be a much, much harder problem. So somehow I have 2 numbers that multiply to 60, and somehow they add to be -11. So I could have a 1 and a -60 would multiply, but they don't add up correctly. I could have 2 and -30. They multiply, but they don't add up. 3 times -20, they multiply, but they don't add up. And 4 times, there it is. You can see that the product of 4 and -15 are going to add up correctly. So where that becomes helpful is that when we get onto the next piece of factoring, if you can do diamond problems, we can do kind of what we just did with those algebra tiles in a much easier way. So I'll kind of try to show you what I mean by that. So if we had x squared, let's say plus 10x plus 24. Here's how we do diamond problems. And I usually just draw the x that you see right here. If this is really a diamond problem, I just don't bother to draw the full diamond. I lost some of my algebra tiles. But remember, A was 1, B was 10, and C was 24. The top right here is A times C, and the bottom number is the number 10, which is B. So now I've got to think through some numbers that multiply to 24, but somehow add to be 10. So I think you could probably figure out pretty quickly that 6 times 4 is 24, but 6 plus 4 is 10. So that's a pretty good thing. Now, here's how we do these problems. We're going to make what is called a generic rectangle. And the generic rectangle is really a picture of what we generated with those algebra tiles. And so if you look at the story, the x squared that we have right here goes in that spot. The 24 that you have goes in that spot. So let me see if we do this. So x squared, the first piece goes here. The last piece right here goes here, but you're going to notice that we have a little bit of a problem because I have 2 boxes left and I've got to figure out what in the world am I going to do with this 10x. What am I going to do with this 10x? Well, what we're going to do with this 10x is we're going to use these 2 numbers right here. We're going to use 6x and we're going to use 4x. So this diamond tells me how to break that thing up. And so again, these problems can get harder, but as I mentioned earlier on, the way you got x squared is if this is an x and that is an x. The only way that the area of this piece can be x squared is x times x. And so if this piece is 4x, it has to be x times 4 because 4 times x is 4x. And right here, you'll notice that x times 6 is 6x. And you'll notice right here that 6 times 4 is 24. And so if we could use the diamond to create our rectangle, then this dimension is x plus 4 times x plus 6. And that is just as good as using algebra tiles, but notice if we used algebra tiles, I'd have to count out 24 of those crazy little things and 10 of those, and you probably could hear in the video that I'm having them fall on the ground around me because as I try to work, it's hard, I keep bumping them. So we're going to do one more. So I'm going to do x squared minus 2x minus 15. Now again, understand, a little bit harder. A is 1, B is negative 2, C is negative 15. So in what I told you to do, we're going to write the product of A and C goes on top. That's negative 15. I'm going to put B on the bottom. That's down here. And I've got to think of 2 numbers that multiply to negative 15, like negative 1 and positive 15. Maybe positive 1 and negative 15. There's all sorts of options. But if you took a 5 times 3, I'd get 15. But if I made it a negative, negative 5 times 3 is 15 negative. And negative 5 plus 3 is negative 2. And so again, how we make our generic rectangle is we start here. Again, x squared starts off our journey, whatever this one is. And sometimes you get something harder and somebody's mean and they put a 2 or a 3 or a negative 2 there. You put it right here. Whatever this is goes in that hole. Then we put our minus 15 in the bottom. That goes here. That's always going to be C right there. And then the last 2 pieces to get that negative 2x, we're going to take the negative 2x here and here by taking these 2 numbers, which is negative 5x and 3x. And of course, there's an obvious question that people say is, does it matter which one goes where? And it really doesn't. So the only way I could get x squared is x times x. We always start it with that place. And if this is 3x and this is x, x times 3 is 3x, and x times negative 5 is negative 5x, and you'll notice that 3 times negative 5 works. So my factor is x plus 3 times x minus 5. Hopefully that was helpful to you. And then I will post the assignment that is in there in Classroom so you can actually practice some of those and follow along. And hopefully you'll be back in class soon. All right, see you later.